Now we can use our methods for solving quadratic equations to approach problem solving with polynomials. Go ahead and take a second and read the example that we have here and try and identify the important information. Here we're modeling height and time given this equation. The first thing that we want to do is we want to solve this question. How long until the rocket reaches the ground? We're solving how long, which means we're solving for time. Which means they have to give us information about h in order for us to solve the equation. That's given by the reaches the ground. At the ground, height equals 0. So we can actually go ahead and set height equal to 0 in our equation. And then we can use our factoring techniques to solve. Now in this one, we only have a binomial. So the first thing we want to look for is a greatest common factor, which in this case is negative 16t, which leaves us with t minus 9 when we factor out the GCF. Since it's factored, we can now go ahead and apply our zero factor property. We can set all the factors equal to 0, and we get two values of t. Well, we have two answers for time, and we only need to figure out one, how long does it take to reach the ground? Well, let's think about what happens. We have a rocket that goes up, and then it comes back down. And when it reaches the ground is this time over here. Well, it started at time equals 0 on the ground, and then it ended at 9 seconds. So it took 9 seconds for it to reach the ground. Next, we want to answer the second question, which is how long until it reaches 224 feet. Now, like the previous example, we're solving for time, but this time we're looking for the height of 224. So we substitute height with the new value, write our equation in standard form. Let's go ahead and pull 16t squared to the other side. That way it's positive. And then we'll factor it. There is a GCF of 16 again, leaving us with t squared minus 9t plus 14, which then can be factored further as t minus 2 and t minus 7. Now we set our factors equal to 0. 16 does not have a variable in it, so we do not need to set it equal to 0. And we get two values of t, 2 and 7. So again, let's think about what's happening. So in order to reach a height of 224 feet, it does it once after 2 seconds and then again after 7. And so it first reaches that height at 2 seconds. And so interpreting the question would be dependent upon how the question is phrased. In order to interpret the answer, if it wants the first time, it's 2 seconds. If it wants to know what times it reaches, then we would list both numbers. So we want to read the question carefully to determine which values we need. Throw back to our geometry days, we have our Pythagorean theorem, where we have the sum of the squares of the legs is equal to the square of the hypotenuse. Which leg is A and B doesn't really matter because addition is commutative, but the hypotenuse is really important. It's always going to be opposite that right angle, and so we need to consider that whenever we're looking at models or drawing our own diagrams. Go ahead and read example B and see if you can draw a diagram that models the scenario that we're trying to solve. Basically what we're looking at is trying to find a right triangle whose side lengths are 3 consecutive integers. So let's start with drawing a triangle. Well, consecutive integers means one after another, such as 2, 3, and 4, or 5, 6, and 7. These are all consecutive integers. And so to go from one number to the next, we're just adding 1 repeatedly. Well, if I don't know how long my first side is, but I know the second side needs to be consecutive, I can add 1. And if the third side needs to be consecutive, I can add 1 to the second side, which gives us a total of x plus 2. So now we have our three sides. We can use our Pythagorean theorem. Which one's A and which one's B doesn't really matter, as long as our hypotenuse is C. X squared plus x plus 1 squared equals x plus 2 squared. To get in standard form, let's go ahead and square our binomials. We can use our formula for a binomial squared to make our life shorter, or our work shorter, not our life shorter. Make our work shorter, and then we want to combine like terms. And then write our equation into standard form. So we have x squared minus 2x minus 3, which can be solved via factoring. 0 factor property, and we get two values. Now length can't be negative, so we need to ignore the negative value. So the length of the shortest leg has to be 3. Since the shortest leg is 3, the next consecutive value will be 4, and then a hypotenuse of 5. So the legs are 3, 4, and 5.